This is worksheet 15.1, and let's look at these first two problems, which are asking you first to find the sum of the numbers from 1 through 10. So if we were to just add up all of the integers from 1 through 10, the dot 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 represents the fact that all of the numbers between 2 and 9 are included also. So if we were to add up all of these integers, we would get a sum of 55. In order to do some of the other problems in this lesson, we're going to basically come up with a formula that we can use to find the sum of a set of numbers without having to add every single number together. So let's look at a pattern that emerges here as far as the sum. If we look at the first and the last terms, they add up to a sum of 11. Then if you look at the second term and the second to last term, those also, 9 plus 2, also add up to 11. Same thing happens with the next two. 3 plus 8 is also 11, 4 plus 7 is 11, and 5 plus 6 is 11. So an algebraic expression we can use to find the sum of all of these numbers is basically to take half of the number of terms, so in this case it would be 5, times the sum of the first and the last. So here the sum of the first and last was 11, multiplied by 5, because there's 5 pairs. So as a formula, I'm going to say S for sum of the first n number of terms is equal to the total number of terms, which I'm going to call n, divided by 2, times the sum of the first and the last term. I'm going to call the first term a sub 1 and the last term a sub n. Let's go ahead and actually do 3 and 4 while we're at it using this formula. So if we were to consider this sum now, and we were to rewrite the sum using this formula that we came up with, rather than actually adding up 1 plus 2 plus 3 plus all the way to 30, let's use the formula. So n represents how many numbers there are. Here there are 30 numbers divided by 2 times the first term is 1, last term is 30. So this would be 15 times 31, which is equal to 465.